Okay, can I start, guys, if it's okay with everybody? Should I?
Yes, sir.
Okay, the slide is visible, right? With types of beam written on it, right, Beta? Correct. Can you confirm?
Yes, sir.
Okay. So, guys, we are now going to introduce SFBM topic. Now, before we go to SF as such or BM as such, we need to be clear about certain terms which we are going to use. Okay. In our questions, we may use the word light beam. Light beam means a beam whose own weight is insignificant as far as question is concerned. That means you will not take into account the weight of the beam. Light beam would mean that whatever other forces are given, you will consider the weight of the beam is to be neglected. It will not be given. So you should not start asking for that way. What will happen with the weight of the beam? Because if the word light beam is used, that means beam has negligible weight. When we will draw our diagrams, if we draw the beam with a single line, then we should see that as a light beam so that in the diagram we don't have a confusion. When I represent a beam with a single line, that shall be construed to be light beam. Is that clear, beta? Right? The second type of beam that will be in our question will be a beam of uniform cross section. There will be only two types of beams in our context. There can be multiple times variable beams and all those things. Okay. A beam of uniform cross section. Beam of uniform cross section means the weight of the beam will be significant and it has to be included. But what does uniform cross section mean? That the weight of the beam is uniformly distributed along its length. And if it's a beam of uniform cross section, we will represent it like this. So beam width of uniform cross section. Are these two types of beams clear, beta? Light beam and beam of so that means if you say that this beam is 10 meters long and let us say it weighs 50 newtons, it means the weight of the beam is 5 newtons per meter. That means if you take 1 meter of the beam, the weight will be 5 newton. Okay, that is what it means by uniform cross section. Then there can be beams of non-uniform cross sections. We will not be interested in studying them. The beams may be like this. The beam may be like this, better. Or you can draw whatever fancy idea you can get. You can make a beam of whatever type that appeals you, but this is going to be out of our discussion. So are the two types of beam that we are going to use, light beam and beam of uniform cross section? Are these two terms clear, guys, and how they'll be represented in the diagram? Clear, beta? Class clear?
Yes, sir. Yes, sir.
Okay. Okay. So don't have any confusion about what about the beam weight of light beam and all that. That has already accepted that it has for a light beam, the weight of the beam is negligible. Then some weights or forces will be loaded on the beam. Okay, whether it is a light beam or a beam of uniform cross section, some weights will be put on the beam. Now, the types of weights we'll be dealing with is a weight which is a point weight or a point force. That means this particular weight is acting at a singular point. It is as you, I know nothing can act as a single point. There cannot be a weight acting literally at a single point, but for the purpose of our calculations, a point weight or a point force shall be deemed to be the one which is theoretically acting at a singular point. So that means if I have a light beam and let us say at point C, I have a point weight. So I will represent that point weight like this, and I'll put the value. If the point weight is, let us say, 20 newtons, I'll represent like this. If the same 20 newtons was acting on a beam at a point C, which is of uniform cross section, so I shall be making the beam like this, identifying wherever the point C is, and then I'll put the point force of 20 newtons. This is how I will be representing the point forces. Is that clear, bete? Concept of point force is clear, guys?
Yes, sir.
Okay. Then we have uniformly distributed load. In short, in exams also this terminology is used sometimes, UDL. UDL stands for uniformly distributed load. What does it mean? That the load is distributed at the same uniform rate along the entire spread, whatever the length be. For example, let us say I have this light beam and I have this beam of uniform cross section. I have two beams with me here. Let's say here is A, B, B. Let us say it says there is a UDL, there is a UDL of 30 newtons. The word UDL automatically implies uniformly distributed. A uniformly distributed load of 30 newtons is spread over 3 meters from end A. So what is the problem statement? UDL of 30 newtons is spread over a length of 3 meters from end A. Okay. How will I be representing this UDL in my diagram? And once I represent, hopefully it will be clear. Let us say this distance is 3 meters, guys. That means over this 3 meters, this weight is uniformly distributed. This is 30 newtons at the rate of 10 newtons per meter. Why? Because it is distributed over 3 meters. So the same thing if I have to represent on the beam with uniform cross section, it will exactly be the same. I'll basically be representing this UDL here over a length of 3 meters. So this is 3 meters and it is 30 newtons at the rate of 10 newtons per meter. Any questions on these two weights, point weight or a point force and a UDL or a uniformly distributed load? Guys, any questions on these two types of weights or forces? Let me know.
Sir, UDL, you mentioned here कि UDL is distributed only for 3 meters. So you
No, so
calculated.
this is the what I gave you the question that we are
Yeah.
in what that we have a UDL of 30 newtons spread over 3 meters from end A. So this is what I have specified in my question now. Okay, beta.
Yeah, but if we didn't have 3 meter distributed all over,
Then
then
how?
it will.
Then you'll draw over the full length. If he says full length, you'll draw the full thing over the full length, beta. You'll stretch this
Oh,
thing here,
okay. Okay.
right? Any more questions, guys, on how to represent weights and forces in the diagram? Okay. Next is type of support that the beam will have, because if you don't have you support the beam, then by gravity the beam should be continuing to move towards the center of the earth. If you place your pen on your table on which you're sitting, if your pen represents the beam, so pen has come to rest on the table because the table has supported it. Okay. Your table top would have continued going towards the center of the earth if the four legs of the table were not supporting it. So whereas the table is not full, the tabletop is not fully supported on your floor, it is supported by maybe 3 legs or whatever, 4 legs or whatever. The pen, when you keep on your table, it is supported along the entire length. Okay, so how is the beam supported? Again, there can be point supports. They are also called as knife edge supports because knife edge is like a point. Okay, so if you have a light beam or you have a beam of uniform cross section, now where the supports is, they will change from situation to situation. Let us say we have 2 point supports, one at end A and another 2 meters from end B. What does it mean? It means a point support will be like a point weight, but only thing is it will be acting from downwards. It will be supporting from down. So basically you see, okay. Now, one support is at end A. I will put the support like this. It's a knife edge support. Another support is 2 meters from end B. So I'll put it somewhere here. This is 2 meters from end B. The same thing, if I have to put on the uniform beam of uniform cross section, I will put one at end A and another 2 meters inside of end B. This is how the point or knife supports will be represented in our diagrams. What does it mean? That practically or theoretically rather, these supports are acting at singular point, like the point force from top, they will exert point reaction from bottom downwards. Then we can have support over a certain length or the entire length. I gave you the example of your pen. If you put your pen on your table, the entire pen is supported by the table. That means it's supported over the entire length. Or it can be if you just think, sometimes you take a plank and you try to cover a gap between, or suppose there is a gap, a trench, you want to pass over the trench and you take a plank and you put on the trench, what happens? Some part of the plank is overlapping the ground on one side, other part is overlapping on the other side, and the middle part is not supported. So support can be can be at a point, can be over certain length, or can be over the total length. For example, support over a certain length, if I say, let's say this is the light beam and this is the beam with uniform cross section. Let us say I give you a question like saying, the beam is supported over knife as support at end B and resting over a plane surface over 3 meters or 4 meters or 3 meters from end A. Okay, over 3 meters from end A. What does it mean? That means at end B, I have a knife as support. At end A, I have some part of it resting. So in this case, knife as support would be like this. Here the knife as support would be like this. Then resting over 3 meters. So that means now it is resting over a support for 3 meters of length. Here it will be something like this. If it was full, you will stretch this to the full length. I don't think that needs any explanation. You can just stretch it to full length. Like the pen, if it is resting over the full thing, it can be just stretched. You can have both the sides resting on some length. You can have knife edge on one side, resting on the other side, and those will keep changing the combination of the question. Guys, any doubts on the support type of supports that we are going to deal with? Whatever I have said until now, is that all clear, beta? Last, can you confirm if it's okay up to this point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. Okay. Now, what will be the first step when we have to deal with SFMBM questions is, again, you see, when I said moment of inertia, its applications, I said diagram, diagram, diagram. When we did bilging, I said diagram, diagram, diagram. And I'm continuing with the same thing. Diagram, diagram, diagram. The first thing is you'll have to make a suitable diagram. Okay. And whatever I have described here will help you in making a suitable diagram. So you should not be struggling with this. Okay. This I'll come to you. Cantilever, you can leave it. I'll explain later. Don't worry. Now, here is a question. And now through the question, I'll keep explaining. And can you make a line diagram, or can you make a beam diagram, rather, not line diagram, a beam diagram for this question on display, guys, based on what I've just told you? Just make a diagram of this beam in question. You can read the question on the screen. Then you can compare at least the first part of the diagram. The first step of everything will be the diagram. So if you are comfortable with making the diagram, the first step is well taken then. Okay. If you have made it, then you can light beam type is supported, knife is supported at its ends. The beam carries a 50 meter and 2 meters from end. Okay. I will make the diagram, and if your diagram matches this, fantastic. If it's not matching, please let me know why there was a confusion, because there should not have been any confusion. At its mid length, I can call it as C. There is a 50 Newton downward force. And at another point somewhere here, let's say if I call it as D, there is a 30 Newton downward force. This distance is obviously 2 meters. If this is 2, then this is 3. And this is 3, and this is 5, because the total length of the beam is given as 10 meters. Guys, is this the diagram you made, or did you mess it up somewhere? Please confirm if the diagram was correctly made.
Yes, sir. Same diagram.
Sure, because this holds the key better. If you make a wrong diagram, it's going to lead you in a wrong direction. So let's not take it lightly. It's very, very important. Now, the next step in everything would be, what is happening in this case is, the beam, okay, its weight is negligible, but there are certain weights placed on the beam. Total of 80 newtons has been placed on the beam, even if I disregard the weight of the beam. What will this 80 newton do? This should be basically pushing the beam towards the center of the earth because of the gravitational pull. Now, is the beam going to continue going down? It should have, but it will not. Why? Because it is supported at the two ends. The support at the ends is preventing the beam from moving downwards. Do you agree with me, beta? Correct? Then what is taking the weight? The supports are taking the weight. If you put your pen on the table, what is taking your pen's weight? It's the table which is taking the weight. So here, what is taking the weight of the 80 newtons? It's the supports which are taking the weight of 80 newtons. They are exerting a force on the supports. And as per Newton's third law of motion, to every action, there is equal and opposite reaction. So the beam exerts 80 newtons on support A and B combined, and A and B combined would exert 80 newtons of reaction on the beam by Newton's third law of motion. Do you agree with me? Do you agree with me? Because otherwise, if upward force is not there of 80 Newton, then beam should have been moving down. Or if the upward force becomes more, then beam should move up. But if the beam is neither moving down nor moving up, that means full weight of the beam exerted at the two supports is supported and balanced by an upward reaction acting at the two supports. Guys, do you agree with what I have said, or do you have any, you want to challenge any of my statements which I have said? Have you understood what I said? Yes or no?
But support getting from A and B only, no sir. Point support is at only A and B.
So beta, if I'm telling you, your table is resting at on how many legs on the ground?
Four sir, four sir.
So 4 legs, right? So 4 legs are preventing the tabletop to go down, correct?
Yes sir. Yes.
Correct.
Correct.
Now is it clear?
Yes sir, clear.
Okay. So the weight of the table is taken by what? The 4 supports, 4 legs of the table, correct? Okay. Now guys. So one thing, do you agree by Newton's third law of motion is that the total, so what is happening is there will be some reaction acting at A, let's call it as RA. There will be some reaction acting at B, let's call it as RB. What is RA and RB? They are the reactions acting at the two supports. Okay. Now what happens is, what will be the total reaction? Total reaction is going to be RA plus RB. And how much is it going to be equal to? It is going to be equal to the total downward force, which is acting on the supports. And in our diagram, if you see, the total downward force acting on our supports is 80 newtons. Therefore, the sum total of the two reactions would be 80 newtons. Does everybody agree, or any questions? Clear, beta? Because this will be the first step of every question after the diagram, and we will not be basically then wasting time on calculation of reactions. Okay. Now my first job would be to find out of this 80 newtons, how much is the reaction offered by A. That means how much weight is coming at A, it will offer that much of reaction. The balance weight will come at B, it will offer that much of reaction. So what is the component of RA and what is the component of RB? Okay. For doing that, we will take the moments of what? Of these forces, or the weights, or all the forces. Now I'll ask you a question in this class. Look at this diagram and tell me on this diagram how many total, first give me the total number. How many total forces are acting on this diagram? Listen to my statement carefully. How many total forces are acting on this beam? 4. How many?
4.
Total 4. Anybody who feels only 2, because somebody may still say no, 30 and 50. No, my statement was how many total forces are acting on this beam. 2 of them are acting downwards, that is 30 newtons and 50 newtons. And there are another 2 which are acting upwards. One is RA, other is RB. So let me write them from A to B here. RA is one force. Second is 30 Newton. If I go from left to right, then 50 Newton and RB. These are the 4 forces on our beam. Now what happens is we will take the moment of all the forces, in this case 4, all the forces we can take about any point along the length. You can take A, D, C, B, or you can take any unnamed point also. Technically, it does not make any difference. Okay. However, for simplicity's sake, it is recommended and strongly recommended that you take moments about one of the supports. Okay, beta. Theoretically, the moments can be taken about any support, any point, but what is strongly recommended is you take moment about one of the supports, and our supports are at A and B. So preferably, either I should take moment about A or I should take about B. Choice can be there. Actually, you can take about any. I'm again saying so. I'm not trying to technically say no. If you don't take about A or B, it will be wrong. No, I didn't say so. I'm just saying if you take about the support, your further calculations will be simplified. That's all I'm trying to say. So let us take moments about A. So taking moments about A. Why I have chosen A? Not because it is the left hand. No, please don't misunderstand me. I have chosen A because it is one of the supports. Okay. Taking moments about A. And now you see, guys, let me change the color to, okay, red is already there. Okay. If I take moments about A, if I hold my beam here, then tell me 30 newtons about A is going to cause clockwise movement or anti-clockwise movement? If I hold my beam at A, will 30 newtons cause a clockwise movement or anti-clockwise movement?
Clockwise.
It will cause a movement like this. Exactly the same way, I'm sure you'll agree. We will not draw it every time. I'm just drawing if anybody, this will cause a clockwise movement. And RB will cause anti-clockwise movement about A. If you change the point, they may change from clockwise to anti-clockwise also. So it is the reference that is important. So taking moments about A, and since I see in my diagram, some are clockwise, some are anti-clockwise. So instead of writing clockwise or anti-clockwise, I can introduce the sign convention. Clockwise as positive and anti-clockwise as negative. So all the clockwise movements I'll take positive, and I've written it here because it's not a standard thing. So I have announced this is the convention I'm going to take. And what is the moment? For any force, the moment will be the force itself multiplied by the lever. And what will be the lever? It will be the center of the force multiplied by and it's the distance of the center of the force from the point about which you are taking the moments. In this case, we are taking moments about point A. Guys, my first force is RA. Look at the diagram and tell me what should I do? What should I multiply with what to get the moment of RA about A? RA about A. What should I do, beta, to get moment of force RA about A? Whatever comes to your mind, basis what I have explained. RA into 0. Why? Because the lever of RA is 0. So moment of RA about A will be RA into 0. So whether you put plus or minus doesn't matter. Now, moment of 30 newtons about A. Firstly, it's clockwise. Since it's clockwise, as per our convention, we make it positive. And I'm sure you'll agree, this will be 30 into 2. Anybody who does not agree can interject then and there itself. Don't mess it up, because if you can't get reactions, you can't solve the question, please. So don't say, I'll learn the remaining part of the question, reactions. If I don't understand, it's okay. It will not work that way. Okay. Then the third force is 50 newtons. I'm taking them each force. Now I see in the diagram, it's again clockwise, so sign is plus. 50 is the force. And what is its distance from the point of reference? It's 5 meters. Then the last force is RB. What do I see? RB is causing an anti-clockwise movement, so minus. It will be RB into its lever, which I'm sure you'll agree would be 10. Guys, any questions on this expression that I have made? but
Sir,
I will
RA
explain.
into 0 is a moment for RA. And what about
Yes.
30 into 2? It is also a moment for point D.
It's moment of point D. Points will
Okay.
have moments, is it?
Yes, sir. Point D moment is 30 into 2 and
Did
point
I
C
say
moment
point? Did I say what have you multiplied with what?
RA into 0 means the
No,
weight is
I'm talking about 30 into 2. What have you multiplied?
30 into 2 means weight
What is
into
what is 30? What is 30?
weight acting downwards, which is the
So
positive
it is the moment.
clockwise.
It is the moment of the force, not the point D. It is the moment of force. And you see, what I'm saying is when I wrote 30 into 2, why you don't interject? My only problem with the class is you guys wake up little late every time. Otherwise, you would have revised it with 50 into 5 and RB into 10. What is the moment, beta? What moment of a force? What did I say a while back? Would you like to repeat? What is the moment of a force about any point?
Sir, a point into distance from the point which is force is acting and is multiplied by distance.
Distance from where to where, beta?
Distance from distance is a lever from the
Yeah, but
point.
from where? Distance between what, beta? That's what I'm asking. Distance between
means
what?
the initial point to that point where the weight is acting.
See what are your problems? Did I say initial point? No. I
Still
said
from where
A
we are
is the
taking the
point about
moments.
which we are taking moments. Tomorrow you change this point, then you'll say why that time it was A, now why you're shifting the point. You don't care for the statements that I'm making in the class. That is the problem. I said, and I have written here, taking moments about A. So what do you mean by initial point? There is nothing like initial and final point here, beta. We are taking moments are about axis. So we are here, we are taking moments about A. So moment about A, when you take the kg, what do you multiply the W1 into with 1? What do you multiply with? When you calculate the kg of the ship, beta. You multiply how do you get the vertical moment of a ship?
The distance D into W means weight
W
into
into D. Okay. So why do you do that? Because W is the force. And what is kg? You're taking moments about keel. So that's the lever from the keel. Yes or no?
Yes, sir.
So in this case, firstly, when you say that it is moment of point D, it's a wrong expression. It's a moment of 30 Newton force about point A.
Okay.
Is that clear now?
Yes, sir.
Anybody else has similar problem? Please speak up. Please speak up. When you say, tell yourself the correct thing, you'll get the correct answer. Tell yourself what is the moment of 50 Newton force about point A, and you will get this response by yourself. Yes or no? Correct,
Yes, sir.
beta? Okay. So now it's clear?
Excuse me, sir.
Yeah.
सर ये सौरभ ज्वाइन करना चाह रहा है, कह रहा है कि सर उसको रिमूव कर दिया है मीटिंग से.
I have not removed anybody. I have not removed any. Who's that?
सर ये अपना ही कोई कैंडिडेट, आई डोंट नो, बट मैसेज कर रहा है.
I have not removed anybody from the meeting. My screen is shared here. You can see I have not acted on. He can join again if he is removed. What is the problem?
ग्रुप में मैसेज किया, he cannot join.
So better he'll have to
वही
sort
मैं
it out. I have not removed anybody.
ओके सर.
I have not removed anybody. You can see my screen is shared, beta, through and through. I have not removed anybody from the group. Okay. Tell him to join from phone or somewhere else if he can. You can join from other machine. That's not an issue. Okay. Okay, guys. Is this expression clear? Okay. Guys, when you said 30 Newton is causing clockwise movement about A, what does it mean? It means 30 Newton is trying to rotate the beam in the clockwise direction about point A. Yes or no? You see the direction. What is 30 Newton trying to do? If you hold your pen, let me just come on the screen, on the camera for a minute. Now, if you hold your pen like this and 30 Newton is acting like this, what is it trying to do? Is it trying to rotate the pen? Yes or no? About the support? Yes or no, beta? About the point of reference? Correct?
Yes, sir.
Correct. So what is, anybody has any doubt that now look at, recall the beam, though the beam would not be visible, but it may be on your answer sheet or in your register. Do you agree that 30 Newton is trying to rotate the beam in the clockwise direction about point A? 30 Newtons is trying to rotate the beam in the clockwise direction about point A, because if I take this point, the same rotation becomes anti-clockwise. So guys, when you talk about forces, moments, and all these things, please make sure the reference point is also given as much importance as the force. So do you all agree that 30 Newtons is tending to, let me put off my camera. Okay. Do you agree that 30 Newtons is trying to rotate the beam in the clockwise direction, beta? Yes or no, guys? Please confirm.
Yes, sir.
Likewise, 50 Newton is trying to rotate in the clockwise direction. Yes. And this moment of RB is tending to rotate in the anti-clockwise direction. Okay. When your beam is resting on the two supports, is the beam actually rotating, beta? No. Why the beam does not rotate? Beam does not rotate because the resultant of the moments must be zero. Because if there is a resultant clockwise or resultant anti-clockwise moment, then the beam should be actually rotating. But if my beam is not rotating, what does it mean? If my beam is not rotating about point A, it means algebraic sum of all the moments about point A is zero. That means this has to be zero because the beam is not rotating. Do you agree with me? Now I have made an equation. First I wrote the moments and now I have made it an equation by equating it to zero. Yes or no?
Yes, sir. Sorry, this is Saurabh, sir. I already back, sir. I was disconnected, sir, and I don't know why.
Okay, beta. So, guys, is that okay? Then we cannot basically, the beam is not rotating because there is no resultant movement. Do you agree with the explanation I've given you? Why this equation has become equal to zero?
So can you explain one more time, sir? I was disconnected.
Beta, I don't know where you left and where you have come in, so it will not be, if you're expecting me to start from somewhere beginning, it will not be possible now.
No, not beginning, sir. Only equation. I was disconnected when you are going to take the moment. That time I was disconnected.
Take the moments. With how many moments had I taken with you?
No, not you. I didn't see anyone.
So beta, you थोड़ा सा, I think you'll have to bear with the class यार. ऐसे थोड़ा सा problem हो जाती है बेटा, going back and forth. It disrupts the moment. It disrupts the momentum beta of the class. You see, this disrupts my momentum also because I have certain thoughts which I stitch together and then suddenly somebody says go back.
Only these equations.
I don't know what to say here. We have taken moments about A. So the moment of 30 Newton force about A is clockwise. Yes or no?
Yes.
So we have taken our sign convention saying that let's take clockwise as positive and anti-clockwise as negative, right? Correct, beta?
Okay. Yes.
So we are taking moments about A. The moment of force A about A will be RA into 0. Why? Because the lever is 0. Correct?
Yes.
Correct? Moment of 30
Yes.
Newton force will be plus. Why? Because if you see, this is going to cause about point A, it's going to cause a clockwise movement. Likewise, 50 Newton is going to cause a clockwise movement. So 50 Newton into its lever. Lever from A would be 3 plus 2, 5 meters. So 50 plus. Correct, beta? And RB is causing an anti-clockwise movement because RB is acting upwards. It's causing an anti-clockwise movement. So we have taken minus, and it is RB into 10 because the distance or the lever is 10 meters for RB. From which point? From the point about which we have started calculating the moments. Yes or no, beta?
Yes.
Saurabh, is that clear?
Yes, sir.
Okay, when we do the more questions, you let me know if there's an issue. Okay, I'll address them. Okay.
Okay.
Then I said these moments, some of them are trying to rotate the beam about A in the clockwise direction. That is 30 Newton moment and 50 Newton moment, 50 Newton moment. Some moments are, that is the moment of RB is trying to rotate the beam in the anti-clockwise moment, in the anti-clockwise direction about A. But since my beam is neither rotating in the clockwise direction nor in the anti-clockwise direction, that means the resultant of these moments must be zero. Yes or no, guys?
Yes.
And this gives me the value of RB. Now you understand why I was suggesting you to take the moments about one of the supports. What has happened is by taking moments about A, your RA, this moment has become zero. So RA goes out of the equation. So what happens is you get RB equal to 60 plus 250 by 10, that is 31 newtons. Please have a good look at it. This will be the first step of every question. And let me know if there is any challenge that anybody is facing. Guys, RB is 31 newtons. Do you agree? Or any doubts or any questions?
Yes, sir, 31.
Yeah, I'll be clearing it off and redoing it again. Don't worry. I'll be redoing it because as we explained, the diagram gets marked unnecessarily. So this first step we'll repeat again. And I'll show you what you have to write, and so that up to that particular point, you don't have a problem. Guys, if RB is 31, then please see the working that we have done above. What will be RA equal to?
49.
49. Why? Because RA plus RB is 80 newtons. That is written on top already. And now you get the answer as to why I recommended, not that I insisted, as to why I recommended that you take moment about one of the supports. Because then you can get rid of that one variable in the equation. Otherwise, what will happen is you'll have RA and RB left in this, and then the two equations you'll have to solve through simultaneous equation route, which will unnecessarily be confusing and cumbersome. So to avoid the use of simultaneous equations, I recommended to you at the onset that please try and take the moments about one of the supports. That support could be A or B, that doesn't matter, but it should be preferably taken about one of the supports. So that gives you the reason why I was asking you to please. Are you okay up to this point, guys? So we get RB equal to 31 and RA equal to 40. So we'll write here RA is equal to 80 minus 31 equal to 49 newtons. Now I'll clear this again and I'll make the diagram again and I'll speak the things again as I'm doing. And then you can probably because that will be the first step of every question. Even before SFBM comes into calculations, that will be the first step. First thing we'll do is we'll make the beam diagram. AB. Question says it has knife supports at both the ends, so knives as supports. Length of the beam is 10 meters. The beam is light, so we are represented by a single line. The beam carries a point force of 50 newtons at the mid length, so 50 newtons. I name this point as C. It says another point force at 2 meters distance from end A, 30 newtons. I can call this point as D. Now this is where the beam has been made, the diagram has been made. Okay. Now Next we write is, let us say the reaction at A is RA and a reaction at B is RB. So we write the reactions at the supports. Then we say RA plus RB is equal to 80 newtons. For reasons I've already explained, because the total downward force must be supported by the total reaction. Now we have to take moments we have to find out individual values of RA and RB. So we take moments about any one support. Okay. You can take it about A, you can take it about B in this case. You can take about any third point also, but that will be unnecessarily inviting difficulty to the question. Okay. I took A in the last working. Let me take moments about B this time, just for the sake of clarity. सौरभ वगैरह जो गायब थे सबको हो जाएगा. I have changed my point of reference now, taking moments about B. And I take the clockwise moments as positive and anti-clockwise as negative. Okay, so this is also going to revise, plus you'll get the same values, right? Guys, imagine you are holding the bar, your pen at the other end now. Tell me what will be the now, class, please participate now. What will be the moment of RB about B? What do I multiply with what?
RB into 0.
Does everybody agree? Anybody has any question? Please speak up right away. If you have problem about clockwise, anti-clockwise, about the lever, anything, let me put these lever distances here, 2, 3, and 5. Guys, look at the diagram and tell me what will, first tell me the sign and then tell me what to multiply with what. The moment of 50 Newton about B.
Minus 50 into 5.
Minus 50 into 5.
Very good. Minus 50 into 5. Everybody is good on that?
Yes, sir.
Minus 37.
Sorry?
Minus 30 into 8.
No, minus 15 to 5. Anybody has any questions, beta? Somebody, I heard somebody saying something. No? Okay. Then rest, next you're already telling me minus 30 into 8, right?
8.
And RA will be what? Moment of RA?
RA into 10, sir.
No. Sign. What about the sign?
Plus RA into 10.
Plus RA into 10. And since the beam is not rotating, the resultant of all this must be 0.
0.
And now if you calculate, I don't have to calculate, you can calculate, you'll get RA as 49 newtons. And then RB will become 80 minus 49 equal to 31 newtons. I think this also helps us in revising concept of moment, so that you should not feel that always left hand should be taken or which one should be taken. You can take whichever suits you, whichever you're comfortable with. It does not make any difference to the answers. Have you solved? Is it coming 49, guys?
Yes, sir, 49, sir.
Okay, so that okay. Now next, what will you do, beta? These are the steps going to be for every question, so you can't escape these. Now what I'll do is I put your reaction on the diagram. RB is 31. You see 31 newtons. RA is 49 newtons. Guys, I'll be clearing my screen to go further. I'll start with reactions put in the diagram. Are you comfortable, or anybody has anything to ask? Guys, anybody has any doubt? None? I'm clearing the screen then once again. Now I'll make the diagram with reactions put at both the supports. We have already learned how to calculate it, right? A, B, point support, RB you got as 31 newtons. RA you got 49 newtons. At C you have 50 newtons. Here you have 30 newtons. This was our diagram. Okay, guys. Now, guys, 30 newtons and 50 newton are acting downwards, and these reaction forces are acting upwards. That I don't think is an issue. Okay. Now let's take any 2 points. Let's take any 2 points along the length. Tell me, where do you want to take? You want to take between AD, DC, CB. Where do you want to take the first point?
AD.
AD. Okay, let me take this point here, X. Tell me one more point where you would like to take it.
CB.
CB or CD? What did you say?
Charlie Bravo.
Charlie Bravo. Okay, anywhere you can take. Distance is not immaterial for this. When we come to bending moment, then the distance will also become important. In this question, it doesn't make a difference. So I'm not. Now you see, guys, these points you have chosen randomly out of your choice. What I want you to do is take the stock or do the audit of forces, resultant force on either side of this point. That means on this side of this point and on this side of this point. Take the resultant. On the left of X, there is only one force. What is that? 49 newtons upwards. Yes or no? That is the resultant of the forces acting to the left of X. Am I right, guys? You agree?
Yes, sir.
To the right of X, there are 3 forces which are acting. You have 30 newton downwards, 50 newtons downwards, and 31 newtons upwards. Guys, what is the resultant of these 3 forces with sign up or down? Tell me.
49.
But up or down?
Downward.
49 newtons downwards. Guys, everybody agrees on this? Please let me know if anybody has any question here. What have I done? I've just found out the resultant of forces to one side of this point X. First, I found on the left of X, and then I found the resultant of the forces to the right of X. Does everybody agree that on both the sides, the resultant is 49 newtons? Only thing is, when I came from left end to point X, it was upwards. When I came from right to point X, it was downwards. That's the only difference. Yes or no? Yes or no, beta?
Yes, sir.
Let's do the similar thing at point Y. Let's do a similar thing at point Y. To the left of Y, there are 3 forces. 49 upwards, 30 downwards, 50 downwards. What is the resultant of all these 3 forces to the left of Y? It's 31 newtons downwards, right, beta? Can you see the total? Yes or no? Correct, guys?
Yes, sir. Yes, sir.
And what is the resultant of all the forces to the right of Y? There is only one force. It's 31 newtons, but acting upwards. Again, the same thing we found, that the numerical values are same, signs are opposite. Yes or no? We have found the same thing at both the points, right? Though between the 2 points, the values have changed. But whether you do the algebraic sum or resultant of forces from left to that point or right to that point, in each case, the numerical value comes the same from both sides. Only thing is, signs are opposite. Do you all agree, guys, what I've said here? Yes or no? Class, you agree with this working better?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, remember this, that at X, I'm coming on the camera now. I'll have to unshare this, otherwise you will have problems. At X, from A to X, it is upward 49. From B to X, it is downward 49. Let's remember this only. And I'll unshare the screen now. This is the beam. This is the beam. And where we have the black and white changing, let's say that's point X that you took. Okay. Now, if I hold this beam like this, and I have basically now held like this at point X, then what is happening? The forces to the left of X, they are at this point, they are causing this beam, this white part of the beam to move upwards with 49 newtons. Yes or no? Correct, beta?
Yes, sir. Yes, sir.
And if I hold the white part like this, the resultant of all the forces acting on the black part of this pen, they are causing at this point, at point where I've held it, a 49 resultant downwards. Yes or no? Correct with it? Class, do you agree with what I've said, or you have any doubts? But let me know if there's any concern. See, I want you to agree and align with the understanding. Otherwise, doing the question, I could have just taught you do this, do this, do this, and you will do the questions. But do you agree that this, the resultant of forces acting here, are causing this part at this point to move downwards with 49 newtons? Yes or no?
Yes, sir.
So if I hold like this and these forces are causing this portion to move down by 49 newtons, what are they trying to do? They are trying to break the beam. 49 newtons here is trying to break the beam. Whether I take this side, it is trying to move this up by 49 newtons. If I take this side, it is trying to move the beam down by 49 newtons. So what is 49 newtons doing? 49 newtons is trying to break the beam here at the junction of white and black, that is point X. Whether the beam will break or not, that will depend on the strength of the beam. Not necessary that every beam should break, or at the same time, not necessary that it should not break. It will depend upon how much is the force exerted on the beam and the strength of the beam. So do you agree with my statement before I put off the camera that, yeah, bolo? Do you agree with the statement that at point X, 49 newtons is trying to break the beam? 49 newtons is trying to break the beam at point X. Yes or no? Correct, Pitin?
Yes, sir.
Exactly the same way, 31 Newton is trying to break the beam at point Y.
Right, sir.
And so 31 Newton is the braking force at B, at Y. 49 Newton is the braking force at 49 Newton is the braking force at X. We have just agreed on this, that at X, 49 Newton is the braking force. At Y, 31 Newton is the braking force. And another name for braking or brake is called shearing. Shear means break. Okay. So the braking force at X is shearing force at X. The braking force at Y is the shearing force at Y. So in this example, the shearing force at X is 49 newtons. Shearing force at Y is 31 newtons. Have you understood better what I'm trying to say? And how did I get these values? By just doing the algebraic sum of forces to any one side. So that means, can I now from this little discussion say that shearing force at any point is the algebraic sum. Algebraic means up or down sum of all forces to one side, any one side, to one side of point in question. Do you agree with the statement that I have written here now, guys? Yes or no? Do you agree?
Yes, sir.
Okay. Now, so that means if I have to find shearing force at any point, what do I need to do? I just need to see how many forces act on one side of it and do their algebraic sum, upward and downward, whatever is the resultant, that is the shearing force at that point. We don't have to do from both sides because answer is going to be same. It was 49-49. Only problem was that from one side, if 49 was upwards, from the other side, 49 became downwards. That's the only difference that has happened. Otherwise, the numerical value has not changed. So there is a, by and large, the shearing force concept is clear, but there is a slight issue that if people start describing by saying upward or downward, then the two answers will be different because one will say 49 up, other would say 49 down. Okay, but numerical value for both will be same. We shall address this issue of up and down thing just after this, but please let me know if you have any concerns up to what we have done until this point, Peter. Understood, beta? Guys, is that clear so far, so good? Tell me if there's any concern.
Yes, sir. Yes, sir.
Okay. So now, how is this upward downward anomaly addressed? Now this is addressed. Let me change the color to which color can I use? Yellow, orange maybe. This upward downward thing is addressed by introducing a sign convention. What is the sign convention adopted then? They say if you are doing the algebraic sum of the forces from left to right, that means like this, from left hand to x. This is called a left to right. When you go from left to right, we'll not call the forces as up or down. Then we'll take upward forces as positive and downward forces as negative. Okay. And what have they done? If you go from right to left, that means this way you come to x. This is called right to left. This is right to left. You basically, let me write it, right to left. Okay. When you go from right to left, the sign convention is reversed so that everybody gets the same answer. You don't have to remember both. You can just reverse it. From upward will become negative and downward will become positive. This is the sign convention introduced. A, to remove the word use up or down. 2, to remove this anomaly of sign because you have reversed the sign convention. Now everybody will either get plus or everybody will get minus. You will not get two different answers, from one from left to right and other from right to left. So you have reversed the sign convention so that the results get harmonized because the value in any case was the same. Correct, beta? Understood, beta? Left to right, right to left concept? Is that clear?
Yes, sir.
Bolo bhai logo.
Yes, sir. Yes, sir. Clear.
Okay. Now, guys, you don't have to get confused. Sir, do I have every time to write a sign convention into it? No. Why? Let's agree amongst ourselves that we will not keep playing sometimes from left to right, sometimes from right to left. We have to do it only from one side, no? Whichever side we want to do. And since we all write English from left to right, our natural comfort comes from left to right. Do you agree with that also? Because we write and read from left to right, the language in which we are going to write our exams. So since we write it from left to right, our natural instinct comes from left to right. You must have seen when I took moments from about point A, it must have been more convenient for you to work than working with moments about B. Yes or no? It creates little bit of discomfort because you are not oriented that way, right? So let's agree in the class that in all our questions, we are not going to change from left to right and right to left. We will always go from left to right. And in exam also make sure you continue going from left to right so that you don't have to worry about the sign convention. And when you have to go from left to right, what is positive? Upward is positive, downward is negative. That's all. So when we go from left to right, our upward forces will be positive, downward forces will be negative. And using this, we will keep calculating the shearing force, and then we'll make a diagram. And once we make the diagram, that becomes the shearing force diagram. That means 50% of the question is done. Don't get panicky. I'll clear it again. Let me see if the next sheet is, I've kept the slide for this only. Let me just see. Yeah, it's the same thing. Okay. Let me redraw the diagram here. Okay. Guys, now I will select some points here. I'll select some points here and we will, in a very crude way, don't take down what I'm telling you now. That's only for the purpose of explanation. Then I'll tell you a shortcut way of getting the diagram, okay? So that you don't get stuck. I'll mark certain points and you will help me in calculating the shearing force at those points. We'll go from left to right all the time. So from left to right, upward forces. So when we go from left to right, guys, upward will be positive, downward will be negative, right? So use the sign convention plus minus. Don't say up and down now. I take point 1 just to the left of A. Just to the left of A means I've just taken it at a point which is just before A. That means you have that point 1 and the next point is point A. So that means for practical purposes, A and 1 are same, but they are just points adjacent to each other. Let's say I take point 2, which is just adjacent to point A on the other side. I take point 3 here. Anywhere, I take point 4 just to the left of D. I take point 5 just to the right of D. I take point 6. I take point 7 here. I take point 8 here just to the right of C. I take point 9. I take point 10. I take point 11 just to the left of B. And I take point 12 just to the right of B. So I have taken these 12 points. And we will go from left to right. We have already agreed in the class that we will not keep changing the sign convention every now and then. Now here are my points: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At these points, you'll give me the shearing force. How do you give it? Have you drawn this diagram better? Or you can use the screen. You can use the screen. What I would suggest is, you just, for the first time, just take tier of a small page, and cover the beam to the right of point in question, whichever point you want the shearing force. The right side beam of right to that should be covered. Why? Because we want to see only the forces to one side of it. We don't want on both the sides. Okay. So if you cover this, the right side, at point 1, what will be the value of the shearing force? Are there any forces to the left of 1? Yes or no?
No, sir. 0.
Does everybody agree? Shearing force at 1 is 0. If anybody has any doubts, please don't wait for me to finish. You can interject anytime. Guys, now move your paper to point 2. To the left of point 2, is there any force?
Yes, sir. 49.
Tell me with sign convention, beta.
Plus 49. Plus 49.
So shearing force at point 2 is plus 49. Do you agree, guys? Anybody? Those who are taking time can take their time. Once you are satisfied, please confirm. Okay. Reach point 3 and see what are the forces to the left of 3. The resultant of forces to the left of 3.
The plus 49.
Plus 49. Please take your sheet up to 4. And 4 is a point just to the left of D.
Plus 49.
Plus 49. What will be the shearing force at point 5 now then?
Plus 49 minus 30.
Okay, somebody in the class has said plus 49 minus 30, which becomes plus 19. Does everybody agree with this? Yes or no? If you don't agree, let me know. You're right, beta, but let people confirm if they've understood. Class, anybody has any doubts about shearing force at 0.5 beta?
No, sir.
What will be the shearing force at 0.6? Is there any change from 5 to 6? No. So that means it will remain plus 19, correct? Am I right, guys? At 0.6, it will be plus 19, yes or no? How much would it be at 7 beta? Speak now. I think you speak, then that is better. At least I know you're getting
Minus 19.
Yes, sir, same.
Same, how much? Plus, say plus 19, don't say same. Okay. What would be at 0.8?
Minus 30.
Minus 31.
Okay, that is plus 19 minus 50 minus 31. Okay. At 9, I'm sure minus 31. At 10, minus 31. At 11, minus 31. At 12, how much would it be?
0.
0, sir.
Minus 31 plus 31 becoming 0. Guys, first everybody has to be comfortable with this. Everybody is good about the shearing forces from 0.1 to 12, yes or no? Guys,
sir.
everybody is good?
सर 0.4 और 7 जो है वो एग्जैक्टली डी और सी पॉइंट पे है?
नहीं बेटा, 4 is just to the left of D. Left of D means first you have point 4 and adjacent to that is D. And adjacent to D on the right side is 0.5. So we say 4 is just to the left of D and 5 is just to the right of D. That means 4, D and 5. These are 3 adjacent points, right? Theoretically.
Mm-hmm.
Understood?
Okay.
Like 7, C and 8, 11, B and 12, 1, A and 2. Correct, beta?
Mm-hmm. ठीक है, sir.
Okay. He's already brought up the topic. When I say 1 and 2, they are what basically? They are, one is next to A on one side, another is next to A on the other side. There is nothing between 1 and A, and there is nothing between 2 and A. So if at A the shearing force is at point 1, the shearing force is 0, and at 2 it is plus 49. That means in between them there is only one point, that is A. Yes or no, beta? Between 1 and 2 there is only one point, that is A. Yes or no? What did I tell you?
Yes, sir.
1, A and 2 are adjacent points. Yes or no?
Yes, sir.
So if it is 0 here and it's plus 49 here, then that means where has the change taken place? The change has taken place at A. Yes or no?
Yes.
0 to 49 change would take place where? At the point in between the two. That is only A. So that means basically these 2 points together represent what is happening at A actually. Have you understood what I am trying to say, beta? Guys, have you understood what I'm saying?
Yes, sir. Yes, sir.
Likewise, 4 and 5 have show what is happening at D. 7 and 8 represent what is happening at C. 11 and 12 represent what is actually happening at D. Now, if these shearing force values I plot on a diagram in which on the x-axis I take the length of the beam. So this is the beam on the x-axis, guys. Okay. So I have beam on the x-axis. I have point A, 2 meters from end A. I have point D. This is 2 meters. 3 meters from here, I have point C. And 5 meters from here, I have point B. So this is 2, this is 3, this is 5. On the y-axis, I take the shearing force, in which what units? Whatever is the unit of the force. My shearing force is changing between let's say plus 49 and minus 31. I take a scale, some scale I'll take, suitable scale, right guys? We can take some scale. Now what do? I basically try to draw a diagram based on the values that I have got. And what values have I got? You see, at A, if you see this, at A, the value changes from 0 to plus 49. That means at A, it changes from 0 to plus 49. Do you agree with me, beta? Yes or no? Understood? 1 and 2 represent what? They represent what is happening at A. Yes or no? Am I right, guys?
Yes, sir.
Then it remains plus 49 at 3, remains plus 49 at 4. That means it remains plus 49 up to D here. And at D, it changes from plus 49 to plus 19. That means somewhere here, the change takes place and brings it to plus 19. Then it remains plus 19, plus 19, plus 19 up to C. And at C, it becomes minus 31. then it remains minus 31 and becomes 0 at T. This remains minus 31. Do you agree with the diagram, the graph I have drawn with this these values, or if anybody has any question before I make my comments on it? Have you understood what have I done, beta? I have drawn the shearing force of the beam along against its length, and this diagram is called as the shearing force diagram. Is the concept of shearing force diagram clear, beta?
Yes, sir.
Yeah, I have this here also. Okay. Now I will tell you a shortcut to draw the diagram. This was just to explain what shearing force means, and now you know what sort of diagram it will come in this simple case. Now I will introduce a shortcut, and after the shortcut, once we have done it, then we'll see if there's any doubt, and then if the need be, I can give you 5 minutes break also. Now I'll make the shearing force diagram for this question from beginning until what I have done till now. And then I'll summarize the points that you need to keep in mind up to the shearing force. First is we'll read the question carefully. So first, read the question carefully. It's very, very important. Second, make the beam diagram correct. Make correct beam diagram. Now I have read it carefully. Now I'm making the beam diagram, right? This is the beam AB, supported at the knife as support at its two ends, carrying at mid length 50 newtons and 2 meters from end A 30 newtons. I can call this point as C and this point as D. This will lead to a reaction of RA of 49 newtons at A. We have already calculated, or let me calculate RA and RB. Okay, let me do the full question. This is 2 meters, this is 3 meters, this is 5 meters. Okay. So we have learned how to make the beam. Any guys, first 2 points clear to everybody. Now you will tell me which point you are having the problem, so that that particular point is emphasized upon rather than repeating everything all over. Third,
From point A, RA, sir, from A.
RA is the force at A, not from A. RA is A. RA is the force acting at A. That is the reaction at A.
Okay.
Third is calculate the reactions. Now I'll execute the third step here. Taking moments about A. I'm writing everything. Sometimes I may just start the word and scribble, but I'm speaking everything also. Taking moments about A. Clockwise as negative. My mistake. Sorry, guys. Clockwise as positive. Anti-clockwise as negative. I have 4 forces. I look at the diagram. The beam diagram will guide me through this now. Okay, my eyes on the diagram now, guys. RA into 0 plus 30 into 2 plus 50 into 5 minus RB. Resultant is 0. This gives me RB equal to 31 Newton and RA equal to 80 minus 31 equal to 49 Newtons. And once I get that, now I put it on the diagram. Let me change the marker because I had written 49 earlier and then cancelled it. Well, since I thought I'll start from there, but now, so 49 newtons here and 31 newtons here. Guys, point number 3 is now completed. Any questions? Point 1, 2, and 3 are clear, guys?
Yes, sir.
Okay. Now, the next step is, we will not take 12 points every time or 15 points or 20 points. We'll cut short now. Third is, this is my own terminology, so it's not a standardized terminology. Identify critical points for SF. What do I mean by this? What I mean by this is that identify those points on the beam where you must calculate the shearing force to be able to make the diagram. If you use more points than that, that's okay. That's okay. Only thing is it'll cost you time. But if you take points less than those, you will not be able to get the correct diagram. That is what I mean by the word critical here. When I'm saying identify the critical points, I mean identify those points without which the SF diagram cannot be made. Am I clear, guys? Am I clear?
Yes, sir.
Now, which will be these critical points? They will be the ends. Okay. They will be the points where point forces act. And there'll be third one. When we do more questions, I'll add them here. So remember, I have not closed it yet. Okay. So, but for this question, only these two things are good enough. Tell me at how many points in this beam diagram point forces are acting, guys? Answer my question correctly.
4.
4. Okay.
4, sir.
Very good. Name them from left to right.
A,
ADCB.
Delta, Charlie, B.
Okay, very
ADCB.
good, very good. And ends are AB. So these 4 points fulfill both these requirements, yes or no, beta?
Yes,
Yes.
sir.
Okay. So once we identify them, next is make SF table. See, you follow this point system religiously, you will not have problems. Now, what do I mean by making the table? You make the table for the points that are critical. Okay, you want to have extra points, that's up to you. I don't want to comment on that. Okay, we have identified 4 points. We have already agreed in our earlier discussion that we'll go from left to right. We don't want to get entangled with every time with a sign convention, which one positive, which one negative. When we go from left to right, upward is positive, downward is negative. I have these points here in the upper row, and I'll have the shearing force in which units? Newtons. That will be the same as the unit of these forces, right, guys? Now I make as many columns as the points I have taken. Now I have to make this table for 4 points: A, D, C, B. A, D, C, B. Now guys, put these points. Do not change the order. Do not jumble up the order of the points. Okay. So from left, because I'll be going from left to right, we have already agreed. So the points will be strictly in the same order as they figure in the diagram, beta. They have to be as they are on the diagram. Is this point understood? Is understood, beta?
Yes, sir.
Yes, sir.
Okay. So you cannot, if my diagram is ADCB and in the table you make it ACDB, you have goofed it up, messed it up nicely. Don't expect anything out thereafter. Okay. Now, Then certain cells you have to divide into two. When I say cells, I mean these spaces between A, D, C, B. So in making the shearing force table, please pay attention. Wherever you have the point forces, I'm not saying point load, I said point forces, whether upward or downward. At all the points where you have the point forces, the cells need to be divided into two. Look at the diagram. Out of these 4 points, how many points have the point forces?
4 points.
All of them, sir. 4.
All of them, very good. So all of them need to be divided. Then this is what I mean. If some of them did not have it, we'll leave that out. They'll come in the questions further, we'll see later. Okay. Why have I divided? Because in our earlier working, we said point 1 and point 2, one to the left, one to the right. What have I done now? At point A, the upper part represents just to the left of A, the lower part represents just to the right of A. Upper part of D represents just to the left of D, lower part represents just to the right of D. Now, pick up that same page, pick up the same page, cover up to point A, to the left. So now we'll fill up these columns, these cells in what I'll number only for the purpose of saying. We'll complete them in this order. 2, 3, 4, 5, 6, 7, and 8. And we will not start every other time from left. We'll carry over and only look at the change. Guys, when you covered with the sheet up to point A, the upper cell under A represents to the left of A. Is there any shearing force to the left of A, guys? Cover it and tell me, what is the value of shearing force to the left of A?
0.
0. Now you carry forward 0 to the next cell. Because up to left of A, it's accounted for in 0. Now just go to the right of A, just to the right of A. What additionally comes up now? One additional force of plus 49 comes, making the shearing force plus 49. Yes or no?
Yes.
That means the shearing force has actually changed from 0 to plus 49 at A. That is what this table means. Okay. I carry forward this plus 49 here. That means up to right of A, plus 49 takes care of it. I'm marking it, you don't have to mark it. That means up to this place, accounting is done. From here to the left of D, is there any change taking place in this span, guys? Then your eye has to start doing. You don't have to mark the diagram. I'm marking for explaining. Otherwise, scan your eye. Is there a change taking place in that band? Any new force coming into picture?
No.
Yes, sir. Yes.
What is the new force coming from right of A to left of D, beta? Tell me. Which new
Nothing.
force is coming? Which one is coming? Tell me. Tell me the force.
Left of
Left of D, no change, sir.
Okay, so that means it remains plus 49. Correct, bete? There is no change, right? I carry forward this plus 49 from left of D to right of D. Is there any change? Yes. Minus 30
Yes, sir.
comes into picture.
Minus 30.
It leaves you with plus 19. I carry forward plus 19 and look at the diagram from right of D to left of C. Is there any change?
No, sir.
So it remains plus 19. If there is no change, it will remain plus 19 because up to right of D, there is already plus 19, right? Then what happens at C? Plus 19 up to left of C. The moment I go to right of C, minus 50 comes into picture, making it minus 31. Then from right of C to left of B, now all of you can see it remains minus 31. Then at B, minus 31 plus 31, it becomes 0. Have you understood what have I done? You don't have to write these numbers. These were written only for the first time. Is that clear, beta?
Yes.
Okay, now we make the shearing force diagram. SF diagram from the table. Now you see, my eye is on the table. Let me change to blue marker, and then that will complete my shearing force thing. Here, 2 meters from A is D. Points have to be from the diagram, C, and then I have point B. Okay, at A, it changed. Now you look at the table. At A, I'm just marking it for explanation purposes. You don't have to do, your table has to be clean. At A, it changes from 0 to plus 49. So it changes from 0 to plus 49. This is shearing force in newtons here. Then from here to D, it remains plus 49, you see. And then at D, it changes to plus 19. I'm marking only for the purpose, plus for 19. I'm only for the purpose of explanation. Then from D, it remains plus 19 up to C. Then it becomes minus 31 at C. Then it remains minus 31 up to B. And becomes 0 at B. And this is how I have drawn the diagram. I put the arrows in the table, and I think if you correlate the arrows with the drawing I have done, you'll realize that it's very simple to draw from the table. Yes or no, beta?
Sir, in the table we have to present the values like this. 0 plus.
Beta, this is the simplest and the best shortcut that can be taken. You cannot take more than that. If you try to do anything more, you will have to do much more than what is being done here. Okay, so it's up to you. This is the bare minimum, and this can see you through in quickest of time.
My question is, do we have to write like 0 plus 49, or we can just write the final value of plus 49? That's good enough.
No. 0 plus 49. You have to carry forward. There it was only 0, na beta. You carry forward, na. Then see, it is easier for you also. In any case, you're considering it, na. So what is the harm in writing?
Okay, sir.
In fact, I many a times will write in the top one also. I'll say 90 plus 49 plus 0 plus 49. You can write that also. Always the carried forward value and the change. If you write, it will make things so easier for you also, no better for revision and everything. Right? Okay. So this is how we will make the shearing force diagram of this beam in the simplest of the forms, with the minimum points that are required. Now somebody may say, sir, I'm getting confused. Should I take this point also? If you are in doubt, please take that. Because if you take an extra point, it will not do any harm. But if you miss out a point, then it will do a harm. So that's but also remember that unnecessarily, if you keep picking points, it's making the question lengthier and lengthier. Guys, you can take a 5 minutes break for it's 11:21 we resume, and if I'll leave the screen on here if you want to see, because this was the initial part where there is always a problem. Now we'll be able to pick up the speed, because here the procedure was being explained, and rest I'll speak after we reassemble. So please take a break. I'm leaving it on. I'm not doing anything. You there back in the class, guys?
Yes, sir.
Yeah. Let me know if there are any questions on SF diagram beta before we take some more questions. Now, guys, the SF diagram is very, very important to be practiced for the simple reason, because we are going to use the SF diagram for the BM purposes. Okay. So if you make a mistake in the SF diagram, then your BM is bound to be wrong. Okay. So that is why my today's focus is going to be primarily on SF diagram. Maybe in the end, if time permits, I'll try to introduce BM, but no problems, even if it spills over to tomorrow. But SF diagram, if not correctly drawn, it's going to have severe repercussions on your question, because BM is bound to be then wrong. So let's see some other questions. So just whatever I have said, and now is the time for you to participate. Now is the time for you to participate. So recap of steps leading to SF diagram, guys. I've already recapped those points. What is that? Read the question carefully. Then correctly draw the beam diagram. Get the reactions. Then identify points for SF, SF table, and sixth is SF diagram. Right, guys? This is what we mean by having a recap of steps that lead to the SF diagram. It all starts with the correct beam diagram, because if your beam diagram is wrong, you will not be able to shape your SF. You will not be able to shape your SF as we go forward. Okay. Now, please participate as much as you can, and let me know if wherever you're feeling the doubt. A beam AB 10 meter long is of uniform cross section. The weight of the beam is 50 newtons and is supported over knife as support at its ends. Draw the SF diagram, only limited to SF. Based on our earlier discussion, and if any one of you does not agree with what I am drawing, please let me know your concern. Don't live with your concern. This is how we represent a beam with uniform cross section. Length of this beam is 10 meters. Its weight is 50 newtons. And obviously this 50 newtons is distributed as 5 newtons per meter. It is supported at the knife over the knife as supports at A and B. Guys, is the diagram correct? Yes or no? Yes or no? Please read the question and tell me, do you agree with the diagram or you need any clarification?
Okay with the diagram, sir.
Diagram is okay. Now, there will be reaction RA at end A. There will be reaction at RB. I'm sure, guys, please speak up. What will be the total reaction?
50
newtons. Very good. 50 newtons. Okay. Now, guys, I'll just take you back to the ship. Your ship's displacement comprises of many weights, W1, W2, W3, maybe like this, numerous weights. Okay. These, some are placed in the forward direction, some are placed midship, some are aft, some are to the port, some are to the starboard, some are down, some are up. They are distributed all over the three-dimension body of the ship. Okay. But if I tell you that MV hinge ship weighs 10,000 tons, displaces 10,000 tons, and has a kg of 7.5 meters, what does it mean? That this entire 10,000 tons can be assumed to be acting through this center of gravity, whose distance is 7.5 meters from keel. Am I right, guys? Yes or no?
Sir.
Correct?
Yes, sir.
But does it mean that entire 10,000 is actually physically located there? Does it mean so? Does it mean so that entire 10,000 tons is located at the concentrated at that point? Does it mean so, guys?
No, sir.
It doesn't
No,
mean
sir.
so. So please be very clear. We can have a force which is not acting at a point. But if I have to treat that force for whatever purpose as one, only for the purpose if I have to treat it as one, like I was treating MV hinge ship as one body of 10,000 tons. When you say MV hinge ship is one body of 10,000 tons, then okay, the 10,000 tons can be assumed to be acting through G. But in reality, 10,000 tons is not acting through G. Do you agree with my statements? Yes or no? Is that clear, beta? अरे बोलो भाई.
Yes, sir.
Now, likewise, this beam AB, its weight of 50 newtons is not concentrated at one point. But if for some purpose, if I have to treat beam as one body, then where can that weight be assumed to be acting through?
Center of.
That means if I have to treat it as one body, then only for that purpose, it can be assumed to be acting through its midpoint. Yes or no, beta?
Yes, sir.
Only for that purpose, not otherwise, but weight is not concentrated there. Please be very clear about it. So now, when we have to take moments, for the purpose of moments, I can treat the beam as one body. But when it comes to actual shearing force calculations, then the weight is not concentrated. Then how the weight is distributed along the length will come into picture. For the purpose of moments, I can treat this beam as one body. Understood, guys? Yes or no? Have you understood what I have said? Okay, so now, taking how many forces are then acting on this beam diagram for the purpose of moments? How many forces are acting for purpose of moments?
3.
3.
3.
When you say 3, that means you're treating beam as one force. And if you're treating beam as a one force, then you will have to take it acting through its geometric center or the center of gravity. What have I done? I've used a very light color to put it there because that is not my weight actually concentration. It is only for the purpose of levers I have put it there. So now, taking moments about should I change to dark one or it's okay, guys?
It's a little dark, sir.
Sir, please change to dark one.
Okay. No, it doesn't cost me here. It's okay. Okay. Now, taking moments about A, clockwise as positive, that you can write, anti-clockwise as negative. I'm sure you'll agree it is RA into 0. Now, this weight acting through this point for one body can be assumed will be clockwise. So plus 50 into 5y, because the length of the beam is 10 meters, minus RB into 10 equal to 0. This will give you RB as 25 newtons. I could have done it without calculation also, but then unnecessarily people would have got confused. So I said, let me calculate and show it to you. If RB is 25 newtons, then RA will be equal to 50 minus 25 equal to 25 newtons. Both RA and RB are equal. Both are 25 newtons each. Is that clear with everybody, guys?
Yes.
Any questions on RA, RB being calculated, beta?
Sir,
Okay.
RB is acting upward, so it is like anti-clockwise, na sir? So why? Okay, minus RB. Yes, minus. Correct, sir.
Yeah. Okay, guys. Okay, done. So everybody agrees up to this place. Now, in the last class, in the last question, I had told you how to. Yes, somebody's asking a doubt. No. Okay. I said was we need to identify the key points or critical points. One thing I said was the end points. Second, I said were the point forces. Okay. And now the third I can say is, or in this case, let's stick to those two because the third is not required in this. Now you tell me how many critical points are involved in this. Based on one, I said are the ends. Two, I said the points where point forces act. How many points should be the minimum points for acceptable, guys? Tell me. Based on this. Two is one answer from the class. Anybody? I hope nobody says the 3 because 50 newtons is not concentrated there. Is that clear, beta? Okay. Am I clear, guys? Yes or no? Okay. But I'm just taking this point C for the purpose of practice. I'm just taking, you can avoid it, you can omit it. Okay. You can omit this point. I'll show you. I'll take it in the table. I'll not take it in the drawing. And you'll see that from the drawing, you'll get the same value. So C is being taken as an additional point because as a student, I had a doubt. Should I take point C? Will A, B, and B be sufficient? I have a doubt. Should I take C? So if I have a doubt, I have taken C. Am I clear, beta? Those C is not required. Those of you who said 2 were bang on, you were right. As a student, I am having a doubt. Should I take 3? I have taken the third one. Okay. So the doubt has come from my side and you were absolutely right when you said only 2. Now please, when I ask you the questions, please respond because the more you respond, you will get to know where the gaps lie between what I have said and what you have understood. A, C, B. These are the points, shearing force in newtons. Guys, look at the diagram. Do I have to divide all the 3 into 2? Do I have to divide 1 or do I not have to divide any? 3, 2 or 1 or none? How many cells need to be divided into 2?
The 2 of them.
Which ones? Which 2?
A and B.
A and B. Why? Because A and B have point forces RA and RB. Is that clear, beta?
Yes.
Okay. Now again, imagine you have covered the sheet up to A. What will be the shearing force in the first here where my marker is probing? What will be the shearing force here?
0, sir. 0.
0. I carry forward 0. What is the change taking place from left of A to right of A?
25 newtons.
Plus 25.
Plus 25, so becomes plus 25.
Plus 25.
Now be careful a little bit. I'm warning you so that you don't make mistakes and you feel good in answering. Please look at the diagram. What is the change taking place from A to C? Is there any change taking place in the forces?
No, sir.
5 into
Are you
5,
sure?
sir.
Yes, sir.
Okay. 5 into 5.
Beta, if you cover your sheet this much, then what happens? What happens to the weight of 5 meters of beam? Take your paper to see.
50
You will have the weight of the beam coming into picture. Yes or no?
Yes, sir.
How much? It will be minus 5 into 5 because it is 5 newtons per meter.
Yes.
So it will be minus 25. It will become 0 at C. Any questions? Please have a good look at it. Understood, beta?
Yes, yes.
Okay, anybody in the class who wants to clarify anything on this, because here some of you may still have doubts. Then I carry forward 0. Guys, from C to left of B, is there any change taking place?
Yes, sir. Same like 5 into 5 minus.
Minus 5 into 5 becoming minus 25.
Yes.
And from left of B to right of B, plus 25 comes into
Plus
picture,
25.
becomes 0.
Zeros.
Guys, look, before I draw the diagram, please have a good look at the table. If anybody has any clarification to seek, please do that. Any clarifications required, guys?
Sir, this only thing is just I want to ask in this
Yeah.
starting one that RA into 0 is why it is taken positive, because the force is acting upward and it is
So-
anti-clockwise, sir. So it should be minus.
Acha, what will be the value of RA into 0? What will be the value, beta?
Sir, value will be 0, sir.
So you put minus against it if that makes you happy.
Okay, sir.
Okay. So if you want to put by minus, you can put minus. If somebody wants to put plus, they can put plus. If it is RA into 0, whether you put plus or minus, is it going to change anything, beta?
Hmm.
Is it causing any moment?
No, sir.
So if it is not causing, then it is neither 0 nor minus.
No, I haven't
Okay.
not calculated. I've just seen that.
Array RA into 0, what is there to calculate, man? You're multiplying
Nothing.
by 0. What calculate? You need a calculator for that. RA into 0, you need to calculate, beta.
No, sir.
Then you're multiplying a number with 0, guys.
Understood.
Okay.
Yes.
No problem. Keep asking. It's okay. Guys, everybody happy with the table?
Yes, sir.
Now, why I told you that beam diagram needs to be correct is because beam diagram will be required to shape the thing. And now I will not use this value to draw the diagram. And we'll draw the diagram with A and B, and you'll see if the diagram is drawn with A and B only, we still get the C from the graph. We'll get that as 0. So we'll draw only with these two things. A, B. I have not done anything now. Okay, beta. What happens at A? At A, it goes from 0 to plus 25, right? Correct, beta? So let us say this is plus 25, this is minus 25. From A, at A, see, this is only I'm doing for you, not for my own sake, 0 to plus 25. Okay. Which is the free end of this line? This is, I'm circling only for the purpose of, this is the end free which has to be joined to the next end. What is happening at B? It goes from minus 25 to 0 and terminates at 0. That means at B, it is like this, and this is finishing at B. This is the free end. This is minus 25. Now I have to join this plus 25 with minus 25. Now they can be joined in infinite ways, straight line, curves, different curves. They can be joined in different ways. Do I join them with straight line? Do I join them with a curve? If with a curve, what sort of curve? The answer lies in the beam diagram. Guys, when I go, disregard C here now. When I go from A to B and I divide this beam into 1 meter sections, is the change in force taking place at a uniform rate? Yes or no? From plus 25 to minus 25, is it changing at a uniform rate? Yes or no?
Yes, sir.
When the change is uniform and you draw the graph of anything which is changing uniformly, its graph is always slanting straight line. So whenever the rate of change is uniform, the graph is always, remember, slanting straight line. Here it is uniform. It is changing at 5 newtons per meter because of the weight of the beam. Therefore, its graph will be a straight slanting line. That means I'll pick up my scale, put it on these 2 points, and just join them with a straight line. And this will be my shearing force diagram. The green one is the shearing force diagram for the question. And what do you see? Where is it cutting the x-axis at the mid length? Yes or no?
C.
And what did we get in the table? We got in the table also 0. In the graph also we are getting 0. this diagram has been drawn without using C. And so whether if I was in doubt, I picked up C, never mind. If I was not in doubt, I could have left it. My things will not change. Guys, have you understood the shearing force diagram, why it has been made straight line? That's important to understand because you're drawing with minimum points. And when you draw with minimum points, you need to be absolutely spot on about the shape. Otherwise, if you take many points and waste an hour on this, then automatically the points will fall in straight line. That's okay. But if you're doing with limited points, then you need to be very careful. Is the SF diagram for this question clear, beta? Simple question where I wanted to bring in the beam of uniform cross section. Is that clear, beta? Okay. Okay. We take one more. In which I have created, this is only for practice purposes. I've created everything, mixed up everything, and please participate. A beam AB 10 meter long is of uniform cross section. So the beam is of uniform cross section. As I'm reading, I am also making the diagram. So this is the beam. AB 10 meter long. It weighs 50 newtons at the rate of 5 newtons per meter, right? It is supported over a knife as support at its left end. It's supported like this at the left end, okay? And rests over a plane surface over 4 meters of length and from end B. It rests over a plane surface over 4 meters at end B. So this is 5 meter, 5, 4 will be somewhere here. It is resting on a plane surface at end B. This distance is 4 meters. It carries a UDL of 30 newtons over 3 meters length at end A. So this is 5, somewhere here will be 3. There is a UDL here of 30 newtons at the rate of 10 newtons per meter. Why? Because it is over a length of 3 meters, right? It also carries a point load of 10 newtons at its mid length. Draw the shearing force diagram. Now, before we start talking of the diagram, please read the question. See if you agree with the beam diagram first. It's very important that the beam diagram is correctly made before you proceed with the question, because otherwise, if the beam diagram is wrong, your output is definitely going to be wrong. You cannot be right in any manner whatsoever. Anybody has any questions to ask on the support? I put in a point support. I put in a plane support. I put in a UDL. I put in a point load. I've taken the beam of uniform cross section. So practically, other than the light beam, everything else that we have discussed until now is included in this particular question. Is this clear, bete? Anybody has any questions, guys? Please speak up. Okay. Anybody who wants to tell me what should I do for the purpose of calculating the moments? For the purpose of moments, the objects or the weights have to be considered as one unit, like the ship, as we did in the previous question. So which all forces you think we'll have to take as acting through their centers? Which all forces?
15.
Okay, let me change to a yellow marker, which is a light one, intentionally, so that it does not become a distraction when we do the question later on. That's why I would suggest you can also use pencil here. We have a beam of uniform cross section. So for the purpose of moments, if it is to be considered as one, where is the weight going to be assumed to be acting through?
Centers are 50 and 10, 16.
Okay, no, keep them separate. Don't make them 60. Let them be separate. Otherwise, there'll be confusion, right?
Okay.
What happens to the UDL? UDL is also not concentrated. How do we deal with the UDL, beta?
Act on one force.
Sorry?
Act on center.
It will become one force, sir.
Yeah, so from where, how do I use it for moments?
So on that center of the 3 meter.
Okay, so assume to be acting through this. I don't have to name these points, right?
Yes, yes.
Is the reaction at the end be concentrated? Is it at one point? Is the reaction at B concentrated?
No, sir. No point.
Then it will be assumed to be acting upwards through its like center of buoyancy, like center of reaction. Yes or no, beta? Correct? Guys, do you agree? Yes. Let me call this point as X. Okay. Now, if you don't understand anything, please, if you ask then and there, it is easier for everybody, for you also, so that you are aligned with the class, if anybody has any questions. So you will have RA acting here, and you can say you will have Rx assumed to be acting here, but it will be distributed over 4 meters. It is not concentrated at one point, right? So now how many forces? I'm just, for the purpose of good order, I'm writing the forces from left to right. You have one force RA acting at A. Then you have a UDL, which can be assumed to be acting through its center. So 30 Newton UDL. Then you have 10 Newton concentrated load. Then you have 50 Newton weight of the beam. And then you have Rx. Guys, 1, 2, 3, 4, 5. 5 forces are there. Am I right? Please check.
Yes, sir.
Now, taking moments about A, clockwise positive, anti-clockwise negative. This time I'll take RA into 0 as minus 2. Okay, beta, happy now? Okay, so yes, RA moment taken. Then 30 Newton, guys, tell me plus minus, and what is it? 30 into what? Plus minus what?
Plus
UDL.
30
plus
times 1.5.
Yeah, but plus minus, beta. Sorry, I missed out if you said plus.
Plus.
30 into 1.5. Very good.
Fine.
Then is 10 Newtons. Plus 10 into how much?
5.
5. 50 Newtons plus 50 into 5.
5.
Minus Rx into how much?
10.
10.
8,
34.
7.
8,
6, sir. 6.
6.
7. 7.
Where can the entire reaction on the right side be acting, assumed to be acting through? It will be acting through its center, yes or no? Into 6, into 8. Yes or no?
8, sir. Yeah, 8. Sorry.
That's why I marked with the blue marker. You mark with the pencil so that you don't make mistakes. Right, beta? A yellow marker I have used for that purpose, so that it is there at the same time. It is not distracting you.
Yes, sir. Yes, sir. 8.
And the resultant will be 0. If you solve this, can you get Rx? Beta, please use your calculator and get the Rx. It is, let me also put on the calculator. 30 into 1.5, 45 plus 50 plus 250 divided by 8. 31.25, guys, am I right?
31.
Is it? $30, $50, $80,
43 is.
43, is it?
43.125.
How much? I made a mistake. How much? 43.125.
Yes. Yeah.
Okay. 43.125 newtons. Okay.
Yes.
Guys, will this be acting at one point? Tell me. This
No.
43.125.
Yes, sir. Yes,
It
sir.
will be acting at one point, is it?
No, it will be divided by 4.
No,
It
sir.
will be
On
uniformly acting over 4 meters. Yes or no,
4
beta?
meter. Yes, sir. 4 meter.
So Rx is 43.125 newtons at the rate of, you divide by 4, it will be 10 point something, right?
781.
781 newtons per meter. Have you understood, guys? At the rate of 10.781 newtons per meter. Understood? Rx is not concentrated reaction. It's distributed over 4 meters. Am I right? Like the UDL is on top, this reaction is distributed from down upwards, right?
Mm-hmm.
Class clear?
Yes, sir.
Okay, guys. Now you have to look at the beam diagram carefully. Two tips I have given you for identification of the points. One is the ends and other are the point forces. Okay, so which all points qualify under these two conditions?
A, B, or center C.
A, B, and center. Okay, we'll name them. Don't worry. Very good. You're right. So as per the two conditions we have done, 3 points already qualify for the table. Ends and the center where 10 Newton is acting. Correct, Bete?
Yes.
Now I will move my laser, and wherever you see change in the forces which are uniformly distributed, you tell me to stop. They will be the points to be considered. I repeat again. I'll move my cursor like this, my laser like this. Wherever you find that the uniform forces, I'm not saying UDL, I'm saying uniform force, whether up or down, wherever the uniform force changes, you tell me stop. I'll take that point. Okay. I'll be gradually going. Please use the word stop for me to stop wherever you want.
Yes, sir. Before that also, when
I go again. Wherever the uniform. Okay. First tell me in this question, how many uniform forces are there? How many uniform forces? 1, 2, 3, 4. How many?
3, sir.
3. Wherever you find there is a change taking place, tell me stop. Sorry?
Stop.
Where? Here?
Yes, sir.
Yes, sir.
Okay. So this will be an important point. Yes.
Yes.
This will be point because of 10 newtons, because of the concentrated load. Then I continue.
Yes.
Yes, sir. This one.
There is a change taking place here in the uniform force.
Yes.
Yeah.
Yes. So we'll have to take 1 point, 2 point, 3 point because of 10 newtons, 4th and 5th. We have to take minimum 5 points. Have you understood, guys? Yes or no?
Yes, sir.
For the table, we'll have to take minimum 5 points. Does everybody agree?
Yes, sir.
Okay, now I'll make the table here. Now we'll name the points. A and B are already named. Maybe we can name C. Maybe name D, E, whatever. Naming is up to you. But make sure once you name them, you stick to that. Okay. So that does not 1, 2, 3, 4, 5. As per my naming, it is A followed by D, followed by C, followed by E, and followed by B. Once you name them, you cannot fool around. Look at the diagram and tell me how many cells need to be divided into 2.
4, sir.
Which all 4?
A.
Tell me.
A, D, E, B.
A, D, E, B. At D, you have any point force? At D, do you have a point force? What was the criteria for division?
Okay, yeah, no.
Okay. Now tell me, how many cells need to be divided into 2?
Then A, C, D. A, C, B. A, C, B.
A and C
Ajay?
only.
A and C. A and C only is one answer. You are saying something else. What are you saying, beta?
A, C.
Where are the point forces? Which are the point forces?
Yes, sir.
A,
Yes, sir. A and C.
There are
A
only
and C.
two. Okay, first tell me also RA. Okay, can you please subtract what if let's RX के बाद RA I didn't calculate. RA will be equal to total downward force is 50 newtons, 10 60, 60 plus 30 90, 90 minus 43.125. How much it comes to, beta?
46.87, sir.
47.
46.87.
Guys, I don't know why you have a confusion. When I asked you which are the uniformly distributed forces, you told me 3. 3 are uniformly distributed, then how many are point forces out of 5 here?
2, sir.
Only 2 are left, no? Then? Yes or no? This is 1 point force, this is another point force. These are the only 2 point forces. Which is the other point force here? There's no other point force. Correct, guys? Yes or no?
Yes, sir.
So only 2 cells need to be divided, A and C. If anybody has any doubts on this, please let me know right away. Okay. Now, what will be the shearing force in the upper cell at A? Cover up to A and tell me.
0.
0.
0. Then what is the change from left to right of A? What is the change taking place?
46.8
अरे plus minus भी बोल ले भाई.
plus, sir.
Plus 46.8. Okay. Okay, 875. Okay. Okay,
Yes.
this will be plus 46.875.
Yes.
Then I carry forward plus 46.875. From A to D, what are the changes taking place? Please see carefully. If you say correctly, it will help your cause.
Minus 30.
What are the changes taking place from A to D?
Minus 30.
Minus 30. Anything else?
Minus 35.
Minus.
No, tell me separate. Don't try to club and confuse. Tell me what are the changes? What
3.
are the changes? I'm not saying what is the total change.
3 into 5.
So minus 30
3 into 5.
and minus
3
15.
into 5.
Minus 3 into 5, right?
5. Yes, sir.
Yes, sir.
Very good. So minus 45 is correct. So plus 1.875, right, guys?
Mm-hmm.
Correct?
11.
11 is it? Okay, 11. Okay, my mistake. Make it 11. So plus 11.875.
नहीं सर 1 ही आएगा ना 45 हो रहा है ना सर करेक्ट
45 हो रहा है ना 1 ही आएगा ना ठीक है
yes.
I thought maybe I made a mistake. Plus 1. Okay, never mind. Plus 1. Okay, guys, look at the diagram. See what are the changes taking place from A to just left of C. D2 left of C.
Minus 5 into
minus 5 into 2, right?
2. Yes.
So this will become
this minus 3 into 5. How you got? Minus 30 is downward. Is minus 3 into 5.
Already calculated. Na?
One second. What are the changes taking? You tell me what are the changes taking place, beta, first from A to D.
A to D is this 30 Newton is the.
That's all. That's all.
A to
Nothing
D.
else.
And then beam weight itself.
So this is the beam weight only, no? 3 meters into 5 newtons.
Okay, copy it, sir. It is beam weight.
Okay. From D to C, it is 2 meters of beam weight. Yes or no?
Yes, sir.
So 9 minus 1, 8 minus 8.125, if I'm not mistaken. Please see if I made any mistake.
Mm-hmm.
Then from left of C to right of C, what happens? You'll have another minus 10 out there. It will become minus 18.125. Yes or no?
Yes, sir.
Correct, beta? Am I right?
Yes, sir.
Okay, then we carry forward minus 18.125. From C to E, there is 1 meter weight of the beam, so minus 5.
Okay.
Minus 23.125.
Yes.
If we have made any mistake, it will not come 0 at the end. Don't worry.
Yes.
Somebody was asking me a inbuilt check in bilging. There is an inbuilt check in this one, not in the bilging. Now from E to B, the changes taking place are 4 meters weight of the beam. So minus 5 into 4, E to B.
Yes, sir.
And the total reaction plus 43.125. Yes or no?
Yes, sir.
Correct? So now this becomes 0. Why? Because 20 plus 23 will become 43. That means all our values are correct. Is that okay with everybody? If anybody has any question, please let me know, beta. If anybody has any question in the class on this beam diagram for shearing force.
Sir, in this particular question, the at the rate 10.781 and at the
doesn't make a difference
is not required.
That would have been used if there was some concentrated load here and if you were to calculate somewhere in between, na bete?
Okay, sir.
If you have gone from E to B, then you're taking the full length, no? So 10.781 into 4 will give you the same thing, no? Because you got 10.781 by dividing it by 4, right?
And yes, sir. Yes, sir.
But if something in between was required, then you'll have to do that, right?
Yes, sir. Correct. So in this question is not required, sir.
Beta, if you've gone from E to B, the entire reaction has come. Now look at it that way, rather than asking ki, in this question not required. From E to B, is the full reaction coming into picture? Yes. What is the full reaction at the right side? 43.125. Correct?
Yes, sir. Yes, sir.
So tell yourself like this. Okay.
Okay, sir.
Any more questions, guys? Now we are good to make the SF diagram. We have, I'll see, plus 46 minus 23. Okay, so that means I need to have a little bit down below and more of it up. I can go up and use a blue marker or green marker to draw. That will solve the problem. Okay. Go up a little bit, no issues. Okay. I need to go up to plus 50. So if this is plus 50, then this is 10, 20, 30. Okay. So 10, 20, 30, 40, 50. And minus 30. Okay. Minus 10, minus 20, minus 30. Okay. Let me put the points first. At A, and then you have A, and 4 meters, 3 meters from A, you have D. This is 3 meters. Then 2 meters from D you have C. 1 meter from C you have E. And 4 meter from E you have B. So this is 3, this is 2, this to the scale, right? And this is 4. So we mark these points. Now at A, you go from 0 to plus 46. Zero to plus 46, somewhere here you go. Okay, you go to this point. From there, you have to go to plus 1.8. So somewhere very close to D, plus 1.1875. Look at the beam diagram, guys. From A to D, is the rate of change uniform, yes or no? Of the forces, total forces. How many forces are coming into picture from A to D? First, tell me the number of forces. From A to D, how many forces are bringing about the change? Look here in the table, no? In the table, how many changes have you made? The table answers.
2.
Are both uniform? Is 30 newtons uniform and the weight of the beam uniform? Yes or no?
Yes.
Yes, sir. Yes, sir.
So the resultant change will also be uniform, correct, Bete? If
Yes, sir.
two forces both are changing at uniform rate, the resultant will be uniform, na Bete? Yes or no?
Yes, sir.
So we'll just put the scale and join this with a straight line. Straight line. From 1.875, it goes to minus 8.125 at C. Minus 8.125, yeah, okay. From D to C, there is only the weight of the beam, you see. It's uniform. So again, put the scale, join them. Then from at C itself, it becomes minus 18. So it comes somewhere here like this, minus 18. From minus 18, it goes to minus 23 at E. So somewhere here, minus 23 at E. Why? Because it's again, if you see in the diagram, C to E is 5 newtons, one weight of it. Then it goes from E to B to 0. I go back from E to B, you have the weight of the beam, which is uniform. You have the reaction, which is uniform. So therefore, the change will be uniform. I join with a straight line. You get this. All are straight lines. All are straight lines, whether vertical or slanting. And this green one is the SF diagram for this question, where you had everything brought into the question. UDL, point force, distributed reaction, point reaction, and weight, beam of uniform weight. Please have a good look at this and let me know whatever doubts you may have. Beta, you're not, I think you're trying to ask something. Come closer to the mic and then speak, Beta. You're not loud.
This point C we cannot directly connect to minus 18.
From D, it will go to the upper cell of C, no? In the upper cell of the C, you have minus 8.125. No, C is divided into 2, Beta. Okay, C, you have a point force, so C is divided into 2, no?
Yes.
No? So it will go to minus 8 first and then come to minus 18, no?
Because it goes to the left side of the street.
Yes, so upper one is just to the left of C, na? So it will go there first, na? Let me just tell you this. See how it is going. From 0, it will come here. From here, it will come here because D is not divided. From here, it will go to this part, and from here, it will come down. Yes or no?
Yes.
C is divided, A is divided. Yes or no, beta? Rest others are not divided, right?
Yes.
Is that okay now?
Yes.
Okay. Guys, I have spent one full session on SF, and there is a purpose. It's an investment because SF will hold the key to BM. Otherwise, I could have parallelly introduced BM and started doing the questions for SF BM combined. But I have put in all this effort onto SF for the simple reason that if SF is clear, BM would follow. But if SF is not clear, BM is going to be wrong. Beta, please, if you are not talking to me, can you mute yourself? Can you mute yourself, guys? Please, if you can mute yourself, please. Okay, so let me know if you have any doubts. Otherwise, what I will request you is all these questions that we have done, you can revisit them for SF, see if you have any doubts. We will, when we do the BM, we'll again have the SF being done on those questions again. So this is not end of SF. SF will be part of BM also. Okay. But SF you need to master to be able to handle BM. And what you need to now do is, if you want to practice more, you can pick up Captain Subramaniam's book or something. He may have taken 10 points on 10 meters. You don't have to do that. You can pick up the key points, do it, and match the value at the points you have chosen. You don't have to worry about the points which are not in the table. And then see if you are able to get this or not. Tomorrow, I will take it a step forward to BM of a beam so that we cover both the aspects SF and BM. If you can revisit these two questions, revisit the steps: A, making of the diagram; B, calculation of the reaction; C, identification of the critical points; D, making of SF table; and lastly, making of SF diagram. These 5 steps, 6 steps, depending on how you break them, these will be the steps that you will be taking to get the SF diagram correctly in the shortest possible time. This is the way you can get it in the shortest possible time so that you don't unnecessarily waste your time in the exams. Okay, so if you have any doubts, I'll be happy to answer.
One request, sir.
Yeah.
Sir, this SF single point and double point we are using, sir. अगर जो आप सर एक बार मतलब लिखवा दे हम लोगों को सर के मतलब क्रिस्टल क्लियर हो जाएगा सर, फिर विल नॉट मिस्टेक।
नहीं, क्या लिखवा दूं बताओ।
कि सर जैसे यहाँ पे भी 2 जगह सपोर्ट है सर, तो इसमें मतलब जैसे पॉइंट वाइज होगा ना सर, जैसे यूनिफॉर्म लोड पे नाइफ लोड पे तो हम डबल लेंगे, और जैसे सपोर्ट में
I told you कि the cells where you have point forces, they need to be divided into 2. That is what I told. उसमें लिखवाना क्या बेटा? इस क्वेश्चन में पॉइंट फोर्सेस कितनी थी तुम बताओ मुझे।
हाँ सर, वो तो मैं सब समझ गया सर कि मतलब ऐसे कुछ वो नोट्स हो गए, ये सिंगल पॉइंट।
नहीं तो नोट्स बता, अरे तो नोट्स तो यही तो बता रहा हूँ तुम्हें, तो तुम लिख लो ना उसको, तुम्हें लिखना है तो बेटा कि जहाँ पॉइंट फोर्स उसको 2 में डिवाइड कर लो।
और सपोर्ट में वहाँ पे सपोर्ट में मिडिल में लेंगे सर बस, या सब मतलब यूनिफॉर्म लोड है
बेटा।
समझ गया सर, मैं समझ गया सर।
उसको मिडिल में लेंगे सिर्फ रिएक्शन कैलकुलेट करने को। When it comes to making the SF table, they will not be concerned. The UDL, uniformly distributed forces, whether reaction or the downward force, they will not be treated as concentrated when it comes to making the SF table. They will be dealt with as a singular force only for the purpose of calculating reaction. Am I clear?
Got your point, sir.
Reaction के time it is like this यार, when you say LCG of the weight loaded is so much, then you're talking of the LCG of the weight loaded. But when you say LCG of the ship, then you're talking of the full ship as one weight, ना? So that's how it basically comes, exactly from the same lines. कि अगर तुम करके देखो, कुछ डाउट होगा तो मुझे बताना ना. Let me see why you're getting stuck then. I need to understand where the problem lies, right?
Yes, sir. सर अभी कोई क्वेश्चंस भी देंगे सर आप अभी मतलब करने के लिए सॉल्व? जैसे 3 तो हो गए,
ये 3 कर लो, ये बहुत हो जाएंगे। अगर खुद अपने आप कर लोगे तो समझ के You make the tables again without referring to the solution. If you do that properly, your problems will be more or less taken care of. Okay. Beta, we'll
Sir,
be
what
doing
about tomorrow timing, sir?
10:30 we agreed yesterday, beta. I'll put on the group also.
Okay, sir.
So 10:30 we start. We take ourselves to BM. And God willing, you should be in position to do some questions by the time we close out tomorrow. And whatever is left from the beam, we can take up day after tomorrow. So day after tomorrow, we'll finish off beam. And we'll basically be also moving to box-shaped vessel. My target is that Tuesday, we should be closing out your SF beam. That is my target, beta. And Tuesday would be what date? I think.
Heavy and chip.
No. And what heavy and chip? What date I said? Heavy and chip.
24.
24.
Okay. Yeah, 25th, 26th, 27th. 25th, 26th, I will finish bulk of your those small topics. I will just have 1 or 2 topics left, which will not be very, well, there the formula I can share with anybody. So 27th, I'll have the class. But if there is any compulsion at your end to move out to your exam center or something, I don't think that should play a vital role. So important components I'll try to cover on 25th and 26th. But 27th, there will be a class. 27th, I'll, in all probability, release you from the stability module better. And that is in good time. You'll have 28th, 29th, and 30th, at least 3 days. And on those 3 days, I'll be available on the group to address any doubts that you may have. Okay?
Sir, which other topics we are going for it, sir? From after BM?
Sorry, beta, say again.
Sir, which other topics we are going to?
Beta, we'll touch upon these important topics from which questions come down, like inclining experiment, heel during turn, then weather criteria, right? Rolling. These questions come in the exam, no? On stability theory and all that. And numericals also come these days. Angle of LOL, GM at angle of LOL. If you've gone through past papers, you would have seen these questions, right?
Do this theory and numericals also, right?
Yes. So if you've gone through, do these topics sound familiar? Have you come across these numericals in the past papers? Yes or no?
Yes, sir, it came, sir.
Yeah, so if these topics sound familiar, then we have to cover them. No, otherwise, if I don't do those topics, then SFPM and everything will go down the drain better. If there are 2 questions from there, then what happens? Then you will be just stranded then.
These also required.
No, that is. I'm not going to leave anything here. Don't worry. Whatever is on my agenda, I'll cover. Only thing is you need to focus upon what is done up to phase 1. That part you need to hedge.
Angle of LOL is coming only from headship.
अरे कहीं से भी आ जाओ ना, तुझे क्या प्रॉब्लम हो रही है? कहीं से भी आ जाओ यार, तुझे कॉन्सेप्ट आना चाहिए, फॉर्मूला आना चाहिए, और वो एनवी इन शिप का नहीं हो, किसी और शिप का होगा तो क्या हो जाएगा? एंगल ऑफ लॉल की डेफिनेशन चेंज हो जाएगी क्या? Why are you so worried? Why you always tax yourself beyond a point here? Okay, guys, go through these 3 questions, revise SF. Let's focus on SF right now. Okay, and full session it's an investment as far as I look at it, because otherwise, in 3 hours, people will take up SF and BM simultaneously. I'm restricting myself to SF because this holds the key. You cannot afford to lose it. Okay, see you tomorrow, 10:30, guys, then.